Okay, quick edit from future me. I kept saying nucleophilic substitution, but these are actually nucleophilic addition reactions in this video, not substitution. So make sure you keep that in mind as you're watching this. I kept saying substitution. So ignore that. It's addition. Sorry about that. Enjoy the video, guys. See ya. Welcome back. Today we'll be doing reactions of nucleophiles. Yes, let's do some. Oh, that says aromatic. It's not supposed to be aromatic. It's just nucleophile substitution. So when we do nucleophile substitution, the reason why this works to begin with is, well, first off, hope everyone's having a great day. But this carbonyl here is more electronegative than this carbon, right? So we know that then, hold on, let's draw a resonance structure. Let's hold things down. So it's gonna be a little small, but just draw it this way. Our residence structure looks like this. Okay, meaning that this negatively charged nucleophile is going to want to attach to the positive charge. And then the oxygen takes back the lone pairs due to electronegativity. Okay. So in step two, we just protonate the oxygen, the negative charge oxygen with an H plus, and then we get an OH plus nucleophile. This is the general mechanism for these type of substitutions. Again, not aromatic. I don't hold on, this is annoying me. Nucleophilic substitutions. Okay. So next we have this one is called hydration. So the way hydration works is again, it's a similar, all of these have the same similar concept where like, okay, right, in this case, H2O is our nucleophile. Okay. So this is our nucleophile. And again, nucleophile attaches to the electrophile, which is here, as we know. And then what happens next is we know when you have an oxygen with three bonds, it has a positive charge. So what I've been telling a lot of my students recently is that just think of orgo as like positive to negative. So then this negative charge, I mean negative to positive, this negative charge is going to go grab this hydrogen, and then this oxygen is going to take electrons back. And then we get something called a geminodiol, which we already went over in the alcohol chapter. Okay, so we call this reaction hydration. So next we have to go over acetyls and hemiacetyls. Also, I want to add acetyls are for aldehydes, and then there is also ketols. So ketols are the exact same thing as acetyls, but with a ketone instead of an aldehyde. So again, the same first step, we know that this carbon here at the bottom is positive, and then we know this carbon here is slightly negative. Okay. So then we do that again, the same process, except this time, if you notice, instead of using an OH, we're using an OR. Okay, so that's really what an acetyl is, a hemiacetyl at least. This is a hemiacetyl because it only has one OR group. So in hemiacetyl is an OH carbon. Well, it's not always going to be an OH. I mean, it's not always going to be a carbon, but remember, you're gonna have one OH group and then you're gonna have one OR group. And that's what we call a hemiacetyl. These are extremely relevant and more of like biochemistry that you're going to see as you're going on through your MCAT studying. So we're going to go through the steps here. So you can also form something called a ketyl. So let's say we have ROH again. Remember, it needs to be ROH, not H2O or whatever we used before. Whenever you add one ROH, you get a hemiacetyl. Okay, remember these could be hemiketyls if this hydrogen wasn't there. And whenever you add a second OR, I mean, you would get a full ketyl. I mean, again, ketyl or acetyl. In this case, it's an aldehyde. So this is what we're going to call an acetyl. Okay. So, and again, these are SN1 reactions. I'm pretty sure. So yeah, just meaning that they happen in two steps and they have some sort of deprotonation. As you see here, the hydrogens are being deprotonated. Okay, those hydrogens are gone. Okay, so next, let's go over amines and enamines. Enamines actually have their own chapter, so a lot of this here is going to just be amine formation. And again, just like everything else, except in this case, we have an NH3, and this acts like your nucleophile. Okay, so in this case, your NH3 acts like your nucleophile. And again, we do the same thing, and it's going to be minus H plus. Right? Because we lose an H plus. We do the same thing. We grab it again, as I've been telling everyone recently, negative to positive every time. And then you take the H plus from here, and then you have another H plus in solution. So we're gonna do a plus H plus. And by the way, whenever you're in acidic conditions, you always have H plus or H2O. H3O, H plus or H3O plus floating around. So you can always use them. So let's go back to why did we just protonate it? Well, we need to make this a good leaving group. And if we made this leave right now, the leaving group would be OH minus, which you can't have. So in acidic conditions, you can't have a negative charge. Like you can't bring in a negative charge. Do you see how we had a negative charge and then we immediately made it neutral, then we made it positive? Right. So you cannot bring in a negative charge, so you won't be able to make it fall off. Because of that, you have to make it positive first, and then you reform. Now, I don't know if you guys remember reforming the carbonyl, is this is a tetrahedral intermediate. So sort of the same thing where now if you just imagine this is like an oxygen, right? It's the same thing. You make a double bond, you make the good leaving group leave. Okay, and this is a good leaving group because the pKa of H2O equals, so the pKa of H2O equals 16. So if you have a pKa of 20 or lower, it's a good leaving group. Okay, so when you do that, when this falls off, when this falls in, making the water fall off, you're then left with this guy. So this is your imine, and then you just lose an H plus. Okay, let's erase these arrows for now. So this here is your imine. Okay, so imines can also turn into what we call enamines, and enamines are easier to recognize, right? Think about the name enamine, so it's an enol and an amino group. And we call this this is sort of like keto enol tautomerization as well, which we'll go over. Hopefully that makes sense. Definitely it's not as bad, very repetitive, but very useful to know. So your enamines and your amines are, this is the formation of the both of them. I haven't, obviously, I don't think you're not going to get a question like form an amine, like on your MCAT test, probably not. But understanding how these form will definitely help you solve a lot of questions, especially low yield ones. And the last one is just the formation of a cyanohydride. I mean, cyanohydride. Um, yeah, this one again, pretty simple. This is a very common nucleophile. I would definitely start as, you need to know this for your test for sure, especially on the MCAT. So again, the same thing here. The CN is the nuke, attaches here. Okay, like we showed here. You go through the same thing. This H plus picks that up. Okay. So these are your reactions with nucleophile substitution. And we're gonna keep going. Next we have oxidation reduction, and this literally would be like a 2-minute video.